Yo, Chuck, what's the move, man? I was on my way up here to the studio, you know what I'm saying? And this brother stopped me and asked me, yo, what's up with that brother Chucky D? He swear he nice. I said, yo, the brother don't swear he nice, he knows he's nice, you know what I'm saying? So, Chuck, I got a feeling you turning into a public enemy, man. Now, remember that line you was kicking to me on the way out to L.A. Lounge in Queens while we was in the car on our way to the shop? Well, yo, right now, kick the bass for them brothers and let them know.
Hey guys, today we're going to be learning about thermodynamics. Now, let me just give you a quick overview before we get into our video. Thermodynamics falls under the category of energy and mechanical actions in physics. It basically deals with conversions from one thing to another with regard to temperature, pressure, volume, as well as mechanical action and work. So that's just a basic overview of thermodynamics. What we're going to be going into today is a lot about conduction, convection, and radiation, as well as microwaves. Those are three big subtopics in thermodynamics that we're going to be learning about today, and basically how those relate to, as I said earlier, pressure, volume, mechanical action, and work. So, I hope you enjoy our video. Conduction is a subunit of thermodynamics. Conduction takes place in solids, particularly metals whose molecules are packed in very densely. An example in the real world of conduction in thermodynamics is when one end of an iron rod is heated in a fire, such as we have here, and eventually the other end of the iron rod will heat up due to conduction, as shown by Bareento.
As you can see here, I am heating this end of the iron rod, and I'm going to prove to you that the heat went through the rod by burning my hand. That's hot. And as you can see there, that's hot.
Next we're going to learn about convection and thermodynamics. Convection in thermodynamics is the principal means of transferring heat through a liquid or gas. Basically anything that tends to flow. It involves the movement of heated material. An example of this, or a good demonstration here, is when hot air rises from the land on a warm day. Heated air has lower density than that of the less heated air in the atmosphere above, and it therefore is buoyant. As shown here, Bareento is the heated air coming from the land. He will move up to where Jimmy is. Then, as it rises, however, it cools as it loses energy. Jimmy shows this by being another set of air molecules moving down towards the land as it becomes warmer. The cooled air now, which is Bareento back at the top of the hill, comes down again as it loses energy and sinks back down and becomes heated again. This creates a repetitive cycle of thermodynamics and convection in nature. Alright, so our third example of thermodynamics is radiation. And radiation, we're going to show you right here in demonstration using a microwave. Microwave uses, I'm just going to get this going first. Shove that in there. Radiation in a microwave is used. Microwave produces wavelengths of radiation that are identical to the vibrations of water molecules in the food or in a drink, whatever you're cooking up in the microwave. And so if you put water or a food containing water in the microwave, such as the meat that we have going right now, then the microwave is going to cause the wavelengths of radiation are going to cause the water molecules in the food to vibrate, and they're just going to keep vibrating, moving around until it's all heated up and ready to eat.
What goes on? Rolling stones of the rap game, not bragging. Lips bigger than Jagger, not sagging. Roll it backwards, I'ma leave it at that. That ain't got nothing to do with rap. Shut the facts, expose those cats who pose as heroes, take advantage of blacks. Your government's gangsters, so cut the crap. A war going on, so we